Metal deficiency defect. What is metal deficiency defect? In this type of defect, metal ion are in deficiency. Metal ion are in deficiency. Okay. In this type, in this type of defect, in this type of defect, metal ions are in deficiency. Metal ions are in deficiency. It is also of two types. First is cation vacancies. First is cation vacancies. And second is extra anion in insterstial sites. Extra anion in insterstial. अरे पढ़े करे के दौड़ हाँ और जगह तो भूया कब देना extra cations vacancies and second is extra anions in insterstial sites. Okay, a point. Metal deficiency defect. In this type of defect, metal ions are in deficiency. Okay, in this type of defect, metal ions are in deficiency. There are two types. First is cation vacancies and second is extra anions in insterstial sites. Okay, first cation vacancies. Cation vacancies. What is cation vacancies? In this type of defect, one of the cation positive ions. In this type of vacancy, in this type of vacancies, one of the cations in this type of defect, in this type of defect, one of the cation positive ions may be absent positive ions may be absent from its lattice side. Okay, in this type of defect, one of the cations positive ions may be absent from its lattice side. The extra negative charge may be balanced. The extra negative charge may be balanced. By an adjacent metal. Metal ion having an extra positive charge. Okay, positive charge. Okay. This is the metal deficiency caused by missing positive ion. Caused by missing positive ions. Okay? Missing positive ions. The metal ion in this case, should be capable of acquiring barrier valency. This type of defect generally takes place in transition metals. This type of defect generally takes place in transition metal. Takes place in transition metals. Okay, transition metals compounds. Okay. For example, this type of defect is found in the crystal of FeO, crystal of ferrous oxide, FeO, ferrous sulfide, FeO, neon oxide, NiO, nickel oxide, NiO, and cupric iodide, CuI, etc. Okay. Then next is extra anion in insterstial site. Extra anion in insterstial sites. It occurs when an extra negative ion. It occurs when an extra negative ions occupies an insterstial position in the crystal lattice. Electrical neutrality is maintained by the inclusion of an extra charge on one of the adjacent metal ions. Okay. It occurs when an extra negative ions occupies an insterstial position in the crystal lattice. Electrical neutrality is maintained by the inclusion of an extra charge This is the extra charge because the charge of two positive ions present on atom A. Okay, extra charge on one of the adjacent metal ion. This has been, you can show this figure. The metal ion in this case should be also capable. The metal ion should the metal ion in this case should be also capable of acquiring variable valency, variable valency, variable valency, since negative ions are, since negative ions are since the metal ions in this case should be capable of acquiring variable valency since negative ions are usually large, usually large. It would be difficult to fit, it would be difficult, it would be difficult to fit them, fit them into insterstial position, them into insterstial position, okay. No examples of crystal showing this type of metal deficiency defect is known till now, okay. Impurity defect. Third is impurity defect. What is impurity defect? Impurity defect. What is impurity defect? Okay. Impurity defect. Impurity defect. Impurity defect. What is impurity defect? This type of defect is produced due to the presence of chemical impurities. This type of defect is produced by the presence of chemical, by the presence of chemical impurities, okay. These are the result of outer atoms are ions, in regular crystals, lattice sites are insterstial position, okay. When outer particles are substituted, substituted for normal lattice size, it is known as substitution impurity, okay. Substitution impurity. When outer particles occupy the vacant interstial position, It is known as insterstial impurity. It is known as interstial impurity. Okay? Impurity defect. This type of defect is produced by the presence of a chemical impurity. These are the result of outer atoms or ions in the regular crystal lattice sites or interstial position. When outer particles are substituted for the normal lattice sites, it is known as substitution impurity. When outer particles occupy the vacant interstial position, it is known as the interstial impurity. Okay, thank you. And next heading is semiconductors. What is semiconductors? And we will be studying about semiconductors in next. Okay.